Can you guys hear me okay? All right. Well, I'm here today to talk about conquering your fear of public speaking because your antenna engineer had to back out at the last minute and force you to come up here and do his presentation. So if you don't mind, I'm going to do a Matt Starling, do a quick video because I got to send it to my mom. She doesn't believe I'm actually doing this. So you got to make me look good. I'm going to send this to my mom, so please. So here we go. Ready? Wi-Fi Design Day. You guys ready? Yeah! All right. Thank you for that. I appreciate it. My mom's going to appreciate it too. So obviously, that's not me. That's Connor Burke. I know you guys were expecting our global superstar to be here, but unfortunately couldn't be here at the last minute, so I'm filling in. Good news is I've got some notes here, so I don't miss something that Connor wanted to let you guys know. And let me get my picture up there. And I was actually a part of this project that we were talking about, or we'll be talking about. I went on site, so I was kind of a part of it and saw, some of the things we did to mitigate the issues. So anyway, we're going to be talking about designing and validating your network in a super complex environment, right? I know you guys have all, designed in challenging environments before. So you think of all of the different challenges you would get in some of these environments and kind of wrap it into one, right? So think of warehousing. You've got super long aisles, right? You've got high density, right? There's a ton of different clients all trying to connect. And then you've got these kind of less than perfect client devices. Obviously, the manufacturers of a lot of these devices are more focused on the ability for their devices to actually work and not necessarily how they are going to impact your network. So we'll look at some of those things. And then we'll specifically look at the manufacturing environment, specifically the automotive manufacturing and electric vehicles, I should say. And as I mentioned, we're going to look at it from the WWCD, right? What would Connor do? Because he's one of the sharpest, brightest minds in the wireless industry. I think a lot of you guys know who he is here. Definitely a superstar. So I'm not going to pretend I'm smarter than he is. So I'll definitely look at it, kind of through his lens. So what makes a complex environment, right? There's a ton of things that go into it. First off, in this specific instance, is the physical building, right? So you've got this massive building, right, that's a couple of football pitches long, super wide, super high ceilings. It's made with industrial concrete, so you've got metal flakes in it, metal beams, metal ceilings, metal everything, right? Basically the scariest Wi-Fi environment imaginable. And then you've got these kind of other pieces and parts, right, like robotic arms and AGVs, or autonomous ground vehicles, physically moving things from station to station, blocking the signal and creating a ton of reflectance. Some of the other things I mentioned, the moving machinery, are the overlay networks, right? So a lot of these, specifically even the AGVs, the guys will come in and they have to have their own dedicated network, right? And they just say, I just need 2 dedicated channels. And then the next guy comes in, and now I have my own dedicated network too, and I need 2 channels, and so on, right? To where you get to the point where you only have, 6 or 8 channels that you're able to use for your network, right? The other thing too is limited mounting. As I mentioned, the building is massive and expansive, so it's not easy to mount something from the ceiling and kind of get the wireless close to the user like you want to, right? It's hard to drop those things down or shoot in from the sides. So limited mounting was a big thing that we tried to solve here. And then, as I mentioned, the client devices, obviously, the logic in a lot of these things isn't the most ideal. So occasionally you can work, which we did in this instance, with one of the manufacturers to kind of push a software update that's a little more friendly to your network. But you just have to kind of assume you're going to get what comes out of the box, right, when you get these things. So you have to plan for those types of things. Some of the other stuff that are challenges, right, is the increased network demands from these high density situations. So you've got roaming VoIP calls on the factory floor. Maybe it's, executives trying to have meetings on the floor, or even the physical workers, talking to each other about where they're at in the process or what's next, or talking trash about how John, is taking a longer lunch break than he should. All that kind of stuff, again, kind of bogging down the network. Lots of IoT devices. I mentioned the AGVs, which are kind of a newer technology, right? I mean, I think the Wi-Fi community is starting to get their best practices underneath them. We're getting to a pretty good place. But every one of these AGV manufacturers is a little bit different, right? So, and what I mean by that is a lot of times they put the Wi-Fi module in the worst possible place, right, underneath the AGV, so it's super hard to connect to. Now, some of them are getting a little bit better, where they'll put them on the sides, or they'll have antennas on the sides to make them a little bit easier to communicate with. But the other thing too is, even if they're not, on AGVs, a lot of times they're moving down assembly lines, and sometimes those assembly lines are even moving. So creating a ton of different challenges. You also have, over-the-air updates, right? OTAs, where they're pushing software to these things, as they're going down the line. So again, a ton of interference, a ton of issues that you kind of have to plan for. So some of the new technologies that we're seeing in these types of spaces, really cool stuff. But again, all stuff you have to plan for, all stuff that's going to kind of, increase your network demands, right? I mentioned the AGVs already. We've also got, again, moving assembly lines and robotic arms that are picking up car chassis and moving them across the building and picking up doors and hoods and, wheels, all these things kind of creating reflectance, right? The other thing we're seeing a ton of prevalence with is smart tools, right? So these tools are becoming more prevalent, kind of wreaking havoc on the network. They're all connected devices to kind of drive performance of the workers, right? They're trying to get things more uniform. They're trying to get things a little bit easier, right? So there's not human input, just making things a little bit more precise. A specific example of that is a smart torque wrench. Right, so you think back in the day, you had a guy going through with a torque wrench, he would have to manually set the torque setting, right? Now these things can be automated via software. So every rivet and bolt that they're doing down the line is automatically tells the guy exactly what to do. So again, it kind of reduces that human input, so they don't have to set the torque limits. And there's lots of smart tools like that. So all great stuff, right? New technology, you get a ton of benefits. As I mentioned, you get faster production, you get more, specialized when it comes to getting some of these pieces and parts on the car, so you're not having to, again, rely on sort of human input. The precision, the quality is much better, and one of the great things it does is provide fantastic analytics, right? So you can look at kind of the performance of the devices, you can look at, how your workers are performing from a key performance indicator perspective. So all great stuff, but unfortunately it comes with a lot of woes, right? So noise being the biggest thing. Unfortunately, all these connected devices are creating a ton of interference, whether it's Wi-Fi or non-Wi-Fi interference from these proprietary systems, really increasing the noise floor. Very challenging to deal with, even in a clean environment, right, with this many APs and this many reflectants. And also the network overlays, as previously mentioned, are reducing the number of channels that are usable for you. So it's having to force you to increase your channel reuse rate in these tight areas, which can be a massive challenge. You've got the mobility challenges, right, that I mentioned. There's chassis and doors and all this metal stuff kind of going through the air that you can't exactly plan where it's going to be, right? Sometimes they're going down a set path. Other times they're going down a path that you're determining sort of as you're moving through the production process. So a ton of woes that come with that. So let's take a look at the initial network, right? When we walked in the building, what did we see? And of course, as Boardman alluded to earlier, they dropped down APs everywhere with internal omnis, dropped super high from the ceiling with drop mounts via conduit. And so, again, not the greatest design, but it's almost like an office environment, right, where you sort of are getting quite a bit of distance. Not optimal, but it should work, right? So this is kind of what they were expecting. You expect to get pretty wide cells of coverage, right, with omnis at those heights. You expect, again, sort of an office environment. You're going to get a ton of distance, and everything should be great. But what they got, they were actually seeing, with the high amount of reflectance in the environment, they were seeing these APs from hundreds of meters away at a legible RSSI value of -80, -79. So, not the strongest signal, but enough to cause interference and really just becomes kind of a corrupted, unusable signal at that point. So now if you add 100 APs into that environment, you start to compound the issue a little bit, and it quickly just creates an unusable amount of interference. So the initial Omni design, obviously didn't work. And they were able to prove this by using the Sidekick. At the time, it was the V1, but they would have been better off with the V2, right, with the spectrum analyzer and the faster sweep speed. So they're able to look at this and realize, okay, we've got to go back and rethink this thing. So what did we do? And again, I ask myself, like I do all the time, what would Connor do, right? Again, one of the sharpest guys in the industry. I've been fortunate enough to work side by side with him for many years, learned a ton from him. Again, not going to pretend I'm smarter than him, so I'll look at it through his lens, right? What would Connor do? And we all know Connor loves antennas, right? So he designs them for a living. He's consistently working with our partners and designing things in Ekahau and kind of showing how the different antennas will work. And so, of course, he wants to look at the antennas, right? So we look at the fact that we had omnis that are really, creating these wide coverage patterns, and stuff's just bleeding over much more than you would expect it to. So we decided to look at directional antennas, so you get higher isolation with nominal side lobes, so you kind of minimize the reflectance. Excuse me. If you go in the new, I'm sorry, let me go back one. I missed one there. And then obviously the mounting situation, right? I mentioned that we want to get these things down so we have clearer line of sight and just a little bit closer to the clients. So we'll look next at the antenna solution. And what we did here was look at a semi-directional 90 by 90 antenna, right? So with 4 dB of gain, so it's pretty low gain, but you're able to provide these smaller cells of coverage, but it's wide enough, kind of acting like an omni on the floor. And if you go into the new AI Pro, or Online Pro, tool, you can start to see these things. A really cool tool that Ekahau gives us, always coming out with unique stuff. So you can see the antenna pattern in 3D. You can see how it's going to propagate in the environment. A lot easier than kind of looking at the 2D spec sheet and trying to figure out which way the pattern's going to go. So again, really unique tool that Matt and friends have given us. So now we've got the antenna solution, right? But now we have to figure out how to mount it. So we came up with this custom mount because they had these I-beams like nicely spaced throughout the facility, right? And again, we want to get these things down as close as we can to the clients and again, create a little clearer line of sight. So our fantastic engineers at ExcelTex came up with this unique design, which was custom, which was now we've brought out to the masses. We do that quite a bit where if you guys are having a problem in a specific vertical, we'll create something for you and then we'll kind of take it out to the masses knowing that, other people in the industry are going to have kind of the same issues. So as you can see, this mount houses the AP and the antenna. Makes it easy to mount. You can put it on these vertical I-beams, drop it down a little bit closer. It's easy to mount the AP. It's easy to service the AP. You can see the indicator lights for troubleshooting purposes. And you can also mount the antenna on the same mount. And now, obviously, you're not going to get away from a little bit of shadow. I mean, these things are wide, metal beams. So we made the antenna mounts a little more universal to where you could lengthen them if you need. So if you need to, on this beam, be a little bit higher out or further out with your antenna, you can do that, or shorter. So we made them really customizable in that aspect. So again, really unique mount that our antennas came out, or our engineers came out with to be able to mount the APs and the antennas. So post-install, what did they get? So as you can see with the 90 by 90 design, it created these nice isolated cells of coverage that they were trying to achieve, in their initial design. As you can see, the APs are still kind of alternating pole to pole, but they're at the lower heights, right? So we get better line of sight. We're closer to the clients. We're able to stay out of the way of some of the moving machinery, as I mentioned, the AGVs and robotic arms and stuff that's bringing those car parts around the facility. The other thing, too, with the directional design is when we did the post-survey or the validation survey, it looked a lot more like what the actual predictive looked like, right? So you were able to go in and see the predictive and know that that's kind of exactly what it was going to look like at the end of the day. Now, the other big challenge was these OTA yards, or over-the-air yards, where they're pushing software to these new cars, right, as they come off the assembly line. And they're coming off the assembly line, self-driven, no human interaction. And you got to think, the first iteration of software they had for location may not have been the best, right, which is why they're pushing an update to it. So they don't want to sink poles out here because A, it would be cost prohibitive. B, you can't have these things running into poles and scratching the paint and denting the bodywork. So big challenge, right? Big open sky above you with clouds and sky. You can't really mount an AP to that, but you still want to try to figure out how to get the Wi-Fi as close as you can to the vehicle. for obvious reasons, but one of them being, a lot of the car manufacturers are not putting the radio in the greatest spot for you. So we came up, again, with a really unique custom mount. We found these poles kind of on each side of the yards, and we're able to create this kind of wire and carabiner system where you could slide the AP out, lock it into place, because as you can see here, there's not, marked paths where the car is going to be. You can't say, hey, go to spot A3. So it may be a couple meters off here and a couple meters off there. So it's important to be able to kind of customize your solution and bring the AP out directly above the cars and get the wireless where you need it. So again, and I'll say it again, our engineers are fantastic, always coming up with cool stuff like this to solve problems. So here we'll look at the 3D models. Again, the AI Pro tool, you can create these 3D models to kind of show a representation of, what the object is, in this case a car, looks like in the actual environment and within that kind of isolated cell of coverage. So again, really neat tool that Ekahau gives us. Created these cute little block cars for us. So what did we fix? The majority of the issues we fixed. First, with the enterprise network, by creating these more isolated cells of coverage, we produced less noise in the environment, and we also created less noise. The overlay networks. Again, because we were forced to use the higher channel reuse rate because of the overlay networks, those isolated cells improve the scheme. Excuse me. And we don't have as much overlap with our dedicated enterprise network. The limited mounting I talked about, so we came up with the I-beam mount that's really versatile to be able to mount the AP and the antenna, giving you kind of the extra options for arms and stuff like that to make them a little bit wider if you need to or shorter if you need to. The limited client devices. Again, I mentioned we were able to work with one of the manufacturers to get a little bit better software update pushed to it. But again, you can't plan on that. So their logic was kind of poor. It was making it so it was roaming to different APs or being super sticky. So again, by creating these isolated cells, we solved a lot of those issues. And then the high reflectance. In an environment like this, you're never going to get rid of all of the reflectance. But we're able to minimize it, again, by getting those isolated cells of coverage, by using our directional, low gain, symmetrical 90 by 90 antenna. So takeaways, off-the-shelf solutions aren't the best fit. Again, as Boardman said, it's not always, green is good. You put a bunch of APs with Omnis up and you get coverage. So going with a custom solution can save a ton of headache, solve a ton of problems, and then obviously, having an accurate survey tool like the Sidekick V2 with the spectrum analyzer is a must, and doing on-site validation afterwards, as you guys all know, is key to life. And then one last thing, Connor Burke sends his love. So I really appreciate your time. Thank you guys. Thanks Open Reality. Thanks Ekahau. Really appreciate it.